Welcome to the video for 5J. Our objective is I will be able to write numbers in scientific and standard notation through the use of rules of conversion. So what is scientific notation? Well, scientific notation is just a way to write very large and very small numbers using exponents, so there is less to write. And the form that we want it in is like this. So we have a number, a, times 10 raised to an exponent. You can also have a negative number, times 10 raised to an exponent. But the important thing is that your number here has to be a number between 1 and 10. It can be equal to 1, but it cannot be 10 or more than 10. All right, so first let's start. If we have scientific notation, we want to put it in standard notation. How are we going to do that? Well, first you're going to slide the decimal point. To the right if the exponent is positive, and to the left if the exponent is negative. The exponent number, so the actual number, tells you how many spaces to move the decimal point. Now let's see why that works. Okay, so we have 3.2 times 10 to the power of 3. Well, 10 times 10 times 10. So if I do 3.2 times 10, that's going to go ahead and move it once. So now I have 32 times 10 times 10. And each time I multiply by 10, it's going to move it to the right. So another way to do this is instead of multiplying it by 10 is just actually slide the decimal point. So I would have, and I'm just going to write it down here so I have room. Here is where my decimal point was. I'm going to go to the right because it's positive. So 1, 2, 3, whoops, 3, not 4. There we go. 3 spots there. And now I can just put in my zeros. So my final answer on this one is 3,200. Now let's look at this one and see why the negative works here. So we have 8.55 times 10 to the negative fifth. Well, the negative is actually going to put this in the denominator. So we actually have like that. And then times 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10. And let's see if I have room here, times 1 over 10. That's what's actually going on here. So each time I'm actually dividing by 10. And when I divide by 10, that's going to move my decimal point to the left instead of the right. So that's where it comes from. But you don't have to always write this out because that's certainly just a lot of extra work. And really all that needs to happen is I need to slide my decimal point to the left 5 spaces. So I'm going to write it up here so that I have room. And I'm going to go left 5 spaces. 1, 2, 3, 4, 5. Put my decimal point, put in my zeros, and then my final answer here, it's getting kind of messy, is 4 zeros. So 1, 2, 3, 4, then 8, 5, 5. This is my answer. All right, if you want to give these a try, go ahead and pause the video and then rejoin me when you're ready, and you can check your answers here. Okay, so 12, power of 12, it's positive. I'm going to move it to the right, so I'm going to go 3, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I need to put in all these zeros. If I didn't want to draw these little bumps here, I could notice that 12 to the right, well, I take off 1, and then the rest is going to be zeros. So right here, you can see why it's much easier to write a big number like this in scientific notation like this. Okay, this one's going to be a little bit easier. We're going negative, so we're going to go left just 1 spot, boop, and our new number is 0, 4, 7, 8. This is also our final answer here. It's just kind of messy with all those bumps in there. Okay, so now let's take a look at taking standard notation and putting it into scientific notation. So here we're going to count how many spaces to make the number between 1 and 10. So to put the number between 1 and 10, I need to move the decimal point so that there's only one digit to the left there. So I need to move it over right there. That'll make this 1.2395. That number is between 1 and 10 because I just have one digit to the left here. That number becomes the exponent. So I went boop, boop, I went 2 spots, so I'm going to go ahead and put in my 10 times 2. And you know what, it's a good point right now it's a good time right now to make the point that in scientific notation, we actually use the time sign. I know that I've been talking to you a lot about no longer using the time sign and just using a dot since we're in algebra, but in scientific notation, we still use the time sign. All right, so that number becomes the exponent in scientific notation. If you move to the left, it is positive, so we're actually doing the opposite as we were above. Positive. And if you move to the right, it is negative. And maybe that's a little counterintuitive, but if you think about it, now that I put my number in here, 2395, whoops, I'm going to rewrite that in a second. This 2 is going to move it to the right. So it's when you put it in scientific notation, you're going to have to think opposite there. So let me just make this a little bit cleaner. Okay, so here we have another number to try. And we need to get a number between 1 and 10. So we want our decimal point to be right here, ultimately. So that we are going 1, 2, 3, 4, 5, 6, 7, 1.395, 2, 6, 8, 4 times 10 to the 7th. Okay, if you're feeling confident, go ahead and pause the video and then give these next 2 a try and rejoin me when you're ready to see how to do these. Okay, on this one, to get the number so that it's a number between 1 and 7, I need to move the decimal point to the right. So I want to get rid of all these zeros and end up with my decimal point right there. So I'm going to have 4.75, and let me count how many times I went over to figure out my decimal point. But it's going to go 1, 2, 3, 4. And then positive or negative on this one? Well, we're moving it to the right, so it's negative. When you're done, when you've come up with your answer, take a look at that and see if it makes sense. If I have -4, well, that means, yep, I'm going to get a whole bunch of zeros over here and make the number smaller. So that does make sense. Okay, how about this one? Well, we're going to move the decimal point all the way over to here, and I get 1.125 times 10. And then am I moving it left or right? Well, I'm moving it left, so it's going to be a positive 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. Okay, so we have a few different types of examples here. Are the following in scientific notation? If not, fix them so they are. So just at first glance, you might go, oh, well, there's a number times 10 to a power, so yeah, it's in scientific notation. But the problem with these is that you actually need the decimal point to make this number between 1 and 10. Okay, it can be 1, but it has to be less than 10. So I actually want my decimal point right there. So in order to change that, I need to move my decimal point to the left 2 spots, which means I'm going to add 2 onto this number here. So this would actually be 1.2345 times 10, and I moved it to the left, so that's positive 2. 2 plus 3 is 5. All right, this one, once again, the decimal point's not in the right spot. I'm going to have to move it to the right. So that I have 1.2345 times, now I have, so over here, I moved it to the left, so I added 2. Here I'm moving to the right, so it's negative, so I'm going to minus 1 from this. So I have 10 to the 5th. All right, how about this one? This one's just fine. You can have a negative and the decimal point's right in the right spot. So we'll just write yes for this one. Are the following scientific notation? Yes. Okay, place the following list of numbers in order from least to greatest. Well, the one with the highest exponent here is going to have the most zeros. So right here, I know this is going to be the greatest. And then the one with the lowest exponent is going to have the least number of zeros on it. So that's going to be the lowest. So place the list of numbers in order from least to greatest. Let's start with our 6.9 times 10 to the 5th. That's horrible. Let me try. And we know way over here is going to be our 7.4 times 10. Sorry, not 7.4. 6.2. And we can go ahead and get rid of these because we've already put them in line. Now we're going to take a look at these numbers that we have left here. They're all going to have the same number of zeros on them. And since all of these numbers have one number after the decimal point, when we put those zeros on there, we're going to have the same number of zeros. We're actually going to end up with 5 zeros on each of these numbers. So then we're actually just looking at these to see which one's least and which one's greatest. I went ahead and wrote them in standard just so you can compare them and get a visual. But our 8.9 times 10 to the 6th is going to be 8,900,000, which is more than 8,500,000, which is more than 7,400,000. So over here goes our 7.4 times 10 to the 6th. Next to it's going to go the 8.5 times 10 to the 6th. And then we're going to get our 8.9 times 10 to the 6th. And then I'm going to bring this guy all the way over there. And I will throw in a comma, and here is my list. Okay, for this first one, it's important to know that you do not distribute this, because all this is, even though we're not using times sign in algebra, is this. That's all it is. Okay, we can't multiply it by both things inside. That only happens if there was a plus sign here, which there is not. And then we would use the distributive property. But multiplication says we can multiply, or the property of multiplication says you can multiply in any order. But here we're not actually changing the order, we're just changing what it looks like. When we get to this one, we're going to change the order a little bit. All right, so we're just going to do 8 times 4.2, 33.6, times 10 to the 5th. Are we done? We are not done, because this is not a number between 1 and 10. I need to move that decimal point to the left, so I'm actually going to make this 3.36 times, and since I moved it over there, I need to add another positive 1 here, so this 5 plus 1 equals 6. This is our answer to this one. And make sure you do not distribute this, because there's not a plus here. We're just going to take half of 1.5, which is 0.75. Times 10 to the negative 4, and we're going to move, that is a decimal point, to the right, make this 7.5, times 10, and since we move to the right, it's a negative, so we're going to take this minus 4 and minus another 1 on there, and we get negative 5. Okay, last one here. Just like I was showing you, all this is time. So we have, mine's kind of, but this is a 1.2. So really, and you don't have to draw the step in here. I just want to show you so you understand. This is 1.2 times 10 to the 5th times 8 times 10 to the 4th. Okay, we can multiply anything together here. So to keep this in scientific notation, I'm going to multiply these numbers together and then multiply these numbers together. So my 1.2 times 8, oops, and I'm going to show my work up here. Okay, I've just changed the groupings on this because I can. And this here becomes 9.6. I'm going to change this to times because that's all that's happening here. And then I have the same base. When I have the same base, I'm just going to add the exponents together. So this becomes 10 to the 9th. And this is a number between 1 and 10, so we're done right there. We don't need to change this anymore. Okay, there was not a spot here on the bottom to write your questions, so make sure you put them on the back of the paper and ask them when you get to class. Thanks for watching.